So, a quick review of what we did last time. We were looking at loops. And we were talking about how we can get some control over our loops. We said loops in Python are very versatile. Python provides a set of control statements that we can use to get even more control out of our loops. Let's take a look at a common scenario that we may encounter to see a use case for loop control statements. And we were looking at how we could use the word break, B-R-E-A-K, inside our loop. So we have a for in loop, but further down in the body we have the word break. And if I just remind you of this example here, so we had dog breeds available for adoption. That was the name of the list, quite a long name. And then we have our square brackets for the 5 elements in the list. So we have French Bulldog using an underscore, Dalmatian, Shih Tzu, S-H-I-H-T-Z-U, Poodle, and Collie. Then we had, so that's the list. Then we had the next line where we just assign a value to a variable. So we said there is this value called Dalmatian, and I'm going to assign it to the variable dog breed I want. For dog breed in dog breeds available for adoption, so that's our for in loop, we're going to print that variable, print dog breed. If dog breed is equal to dog breed I want, colon, print, they have the dog I want, break. And we talked about the indentation of the break line being really quite important. We want the word break to be on the same line as the consequent. Okay, so when I talk about a consequent, this is the language of conditional statements. So any conditional statement has an antecedent and a consequent. So here's an if word, and the if word means I'm about to give the antecedent. So this is the antecedent, this part here. So ante, before, is dog breed equal to dog breed I want? Is the temporary variable equal to the dog breed I want? And remember, we want a Dalmatian. We want a Dalmatian. So that's the antecedent, and then we do a colon, which means, and here's what to do, and that's the consequent. And we want the break to be only considered if you're looking at the consequent. So we don't want someone to come along. We don't want the loop to go through an iteration and go, okay, for every value of dog breed, I'm going to A, print dog breed, B, look at this statement, and C, break. No, we don't want it to break every time. We only want it to go A, print, and then B, consider this if statement. And the idea is that if this antecedent isn't satisfied, then all of this kind of that's within it, that's indented, falls away, because print is indented below the if statement. Break is also indented below the if statement. It's not the same indentation as if, is it? Look, it's further in. Break is further in than if, same as print. So the effect of that indentation pattern is that all of this kind of falls away and isn't acted upon if this antecedent here highlighted isn't satisfied, and that's obviously a good thing, because it means that for French Bulldog, well, this never gets satisfied, so we don't break. For, if we were to go to Shih Tzu, we wouldn't break, because dog breed wouldn't be equal to the dog breed I want. We want a Dalmatian. For Poodle, it wouldn't. For Collie, it wouldn't. However, the exception is for Dalmatian. In that case, the if statement in that case does have sort of blood going through it, and it gets fulfilled. We satisfy the condition. The antecedent is true, we might say, and so we do print, they have the dog I want, and we do break. And so that's the only time we break with Dalmatian. Okay. Loop control, continue. While the break control statement will come in handy, there are other situations where we don't want to end the loop entirely. What if we only want to skip the current iteration of the loop? Let's take this list of integers as our example. 1, 2, -1, 4, -5, 5, 2, -9. So they're not in order. That's okay. We've got some negative numbers, some positive numbers. We're just going to call it big number list. Big. What if we want to print out all of the numbers in a list but only if they are positive integers. We can use another common loop control statement called continue. So let's take a look. For I in big number list, so I is just arbitrary, it's just the name of our prop, our temporary variable. If I is less than or equal to 0, colon, continue, and then we have print. So what does that mean? What does that mean? This would produce the output 1, 2, 4, 5, 2. So you'll notice we only have positive numbers in the output. Now obviously, what's a positive number? It's when I is bigger than 0. So we're saying if I is less than 0 or even equal to 0, in other words a negative number or 0, continue. That seems to be what we're saying. If continue. And of course the word continue is indented within, so that it is within the if line, as it were. So it's not if continue print, it's if and print. Okay, continue is sort of subsumed within the if line. So let's read again. What if we want to print out all the numbers in a list, but only if they are positive integers? We can use another common loop control statement called continue. So it looks like what's happening is we're saying if I is a negative number, pass over it, continue. Otherwise, print I. Because if we take a positive number like 1, that's our first positive number, isn't it? It will consider this, it will say, well, is 1 less than or equal to 0? No, it's not. Okay, fine, move on, leave it then. Don't go to this line, forget about that line. The antecedent isn't satisfied. So we move on and we print I. So we print 1. And then we say, well, I is now going to be equal to 2. Well, is 2 less than or equal to 0? No, okay, forget about it then. Next line, print 2. And we print 2. And then we get to minus 1. And we say, well, I is going to be minus 1 for a little bit of time now. And if minus 1 is less than or equal to 0, well, it is. So finally, we do satisfy the antecedent. So now we do say, okay, continue. So, and then, well, it doesn't get printed, does it? We don't print minus 1. So what does that tell us about how the loop works? It tells us that continue must mean finish. You know, don't consider any more statements in the loop body. Because, as I said, when I is equal to minus 1, we don't print I. We say if minus 1 is less than or equal to 0, and we never print. We never get to this line. So continue must mean, okay, move on. 4, go to 4. Consider the next element in the list. So we do. We go if 4 is less than or equal to 0. Well, of course, it's not. So we ignore the continue line and we do print. So we do print 4. Okay, let's read. Notice a few things. 1. Similar to when we were using the break control statement, our continue control statement is usually paired with some other form of a conditional. So if, elif, or else. 2. When our loop first encountered an element, minus 1, that met the conditions of the if statement, it checked the code inside the block and saw the continue. When the loop then encounters a continue statement, it immediately skips the current iteration and moves on to the next element in the list, which is 4. So if we remind ourselves of the list, we have 1, 2, minus 1, 4, minus 5. 3. The output of the list only printed positive integers in the list because every time our loop entered the if statement and saw the continue statement, it simply moved to the next iteration of the list and thus never reached the print statement. Let's continue learning about control statements with some exercises. Instructions. 1. Your computer is the doorman at a bar in a country where the drinking age is 21. Loop through the ages list. If an entry is less than 21, skip it and move to the next entry. Otherwise, print the age. So here you can see ages, and it has a number of elements. We've got, let's just quickly go through 12, 38, 34, 26, 21, 19, 67, 41 and 17. So fair to say mostly younger people, a few older names there, older ages. So we want to loop through the ages list. So how do we do that? We use a loop. So is it an for in loop for x in y, and we might say I'm going to call it just person. For person in ages, colon, if person is less than 21, well, what do you want to do? Skip it, so I'm going to put continue. Skip it and move to the next entry, otherwise print the age. So on the same level of indentation as if, I'm going to put print person. I think that works. Have I missed anything there? For person in ages, that's the name of my list. If person is less than or equal to 21, continue. Do I need any sort of semicolon after the word continue? Do I need some punctuation here? I don't think so. Print person. Run. And I've got a tick. So let's do a quick check that it's worked. So the first element is 12. Well, 12 is less than 21. So hopefully that hasn't been printed, because we get to the continue. It satisfies this conditional. It satisfies this condition. So we continue. We don't look at this at all. We don't, and that's good. We haven't printed 12. If person is less, 38, that's not less than 21. 34, that's not less than 21. Is 26 less than 21? No. So that should be printed, and it is. 21 should be printed, and it is. 19 should be printed, or should it? No, 19 is less than 21. Continue, good, and we don't print it, and that's good. We don't have 19. Okay. Nested loops. Loops can be nested in Python, as they can with other programming languages. We will find certain situations that require nested loops. Suppose we are in charge of a science class. This is split into 3 project teams. So we have this list called project teams. And we have the first element, which is a list, Ava, Samantha, James. The second element, which is a list, Lucille, Zed. And the third element, Edgar, Gabriel. Using a for or while loop can be useful here to get each team. What does that mean? To get each team. So we've got a for in loop for team in project teams, print team. So that's just going to print out each element. Okay, yeah, that would output Ava, Samantha, James, Lucille and Zed, and also Edgar and Gabriel. But what if we wanted to print each individual student? In this case, we would actually need to nest our loops to be able to loop through each sublist. As you can see, the problem we have, the element is not Ava or Samantha. The element is that list, and there's no way to sort of get into that and scratch beyond that. That is a sort of intact entity. So all we can ever, by just using a single for in loop, all we can ever do is print the whole list in its entirety. So we want to print individual students. Okay, let's look at this code. For team in project teams, this line is a comment, loop elements in each sublist. So now we have another for in line for student in team. And this is indented within the for in, this first for in statement. So we have for team in project teams, and then a line indented within that called for student in team. So both times, no. Okay, so on the first line, the temporary variable is the word team, singular. On the second line, team has become the collection. So we're not saying for team in something, we're saying for student in team. So now team is the collection, the thing after the word in. On this line, we say for team in. Okay. So what we're doing is kind of, in this line, we're diving into the temporary variable that we defined up here. So we say, we'll use another temporary variable, we'll just call it student. So for student in team, print student. So this is just a for in loop within a wider for in loop. And that would actually output Ava, Samantha, James, Lucille, Zed, Edgar, Gabriel. So we've got all the names, they're not in speech marks, they're just bare. And so this idea is called a nested loop. Let's practice writing a nested loop. Instructions 1. We have provided the list sales data that shows the number of scoops sold for different flavours of ice cream at 3 different locations: Scoop Academy, Gilbert's Creamery, and Manny's Scoop Shop. We want to sum up the total number of scoops sold across all 3 locations. Start by defining a variable called scoops sold and set it to 0. Done. Two, loop through the sales data list using the following guidelines. For our temporary variable of the for loop, call it location. Okay, so for location in sales data. 2, print out each location list. Print location. 3, within our sales data loop, so notice they've just adopted a little habit there where they refer to the loop by using the name of the collection. Because I could say it's my location loop, couldn't I? But they're saying no, it's your sales data loop. So just noticing that's what they're doing there, taking the collection that you mentioned and using that to refer to the loop. So this is our sales. So this is our sales data loop. So within our sales data loop, nest a secondary loop to go through each location sublist element, and add the element value to scoops sold. So how do we do that? Add the element value to scoops sold. We use some sort of add equals operator. By the end, you should have the sum of every number in the sales data nested list. So I'm going to put just 4 in again for let's just call it scoops. For scoops in location, scoops sold, add equals scoops. Will that work? Oh, and yeah. And then 4, print out the value scoops sold outside of the nested loop. Print scoops sold. The thing I need to pay attention to here is the indentation of this print function. Hopefully I've got it right. It's at the same level as this line saying print the location, which is the whole list with 3 elements. 4 in, and then print scoops sold. Yep. Oh no. The output does not look quite right. Is your final print statement unindented? No, it is indented. It's not unindented. So maybe they want me to... So look, what's happening here is scoops sold, where it's part of the outer loop. It's part of the, the iteration cycle. And that's why we get 51, 66, 96. In other words, that's why we get it executing 3 times over. So it's 51, and then we add 2 and 10 and 3, which is adding 15. And if you add 15 to 51, it's 66. So we print it again. So it's part of the thing we do on each cycle of the loop. And they're saying we don't want it to be. We don't want it to be. We want it outside the for loop. So we want this print statement to not be part of the body of the outer for loop. That's fine. Fine. Print. And then the last line is 96. Okay. List comprehensions. Introduction. So far we have seen many of the ideas about using loops in our code. Python prides itself on allowing programmers to write clean and elegant code. We've already seen this with Python giving us the ability to write while and for loops in a single line. In this exercise, we are going to examine another way we can write elegant loops in our programs using list comprehensions. To start, let's say we had a list of integers and wanted to create a list where each element is doubled. We could accomplish this using a for loop and a new list called doubled. So let's have a look at this code. So this is we've got a temporary variable called number, singular. Pay attention to that, because we do have a list which is called numbers. So we say for number in numbers, so our collection is called numbers. We're going to do doubled, which is a list name. So we're going to do doubled and append to it the temporary variable, so each element multiplied by 2. So what we're doing is we're filling out, because we're using append, this list, because we do doubled dot append, so we're filling out that list. The list is called doubled, and what are we filling it out with? We're filling it out with the elements from numbers, because remember, the temporary variable which we've used to represent each element in numbers in turn is number, so we do number multiplied by 2. And of course that's double it, so we won't get 2 in there but 4, we won't get -1 in there but 2, we won't get 79 but 158. Okay. And then we print the list. So doubled, again, look, you can see we use the assignment operator and we've put some emptied out square brackets, which means square brackets mean it's a list, but it's empty, that's fine. And then we print doubled, so we're printing out the list. And hopefully when this print function executes, it is full of the elements that were in numbers, but now doubled. So the output would output 4 minus 2, 158, 66, minus 90, and we did predict that. Let's see how we can use the power of list comprehensions to solve these types of problems in one line. Here is our same problem, but now written as a list comprehension. So why are they using the term list comprehension? What do they mean by that? I mean, comprehension means, you know, have you taken it on board? Do you understand it? Are you listening? To comprehend something. It's to experience something in a meaningful way. Here, what they're doing is creating a list from another list, sort of. We're modifying one list, numbers. So we're saying for number in numbers, for the elements in numbers, use the value number to append. So maybe that's... So we're comprehending in the sense that we are we're listening to what's in the list called numbers and doing something with it. So we're comprehending, we're paying attention to what's in numbers. So let's see how we can use the power of list comprehensions to solve these types of problems in one line. Here is our same problem, but now written as a list comprehension. So let's take a look at this code. So it looks quite different to before. We have one list here, and it is assigned to the variable numbers. We have another list here, a thing in square brackets, assigned to doubled. We say num multiplied by 2 for num in numbers. What's going on here? So we've got for in, which is a for in loop, but it's kind of it's inside the square brackets, which we've not seen before. For num in numbers. We understand that's just a print function, but this is probably the most confusing bit. What are the rules here? How are you? I know what num multiplied by 2 is, but how are we able to just do num multiplied by 2 and then a space and then for num in numbers? Num is our temporary variable for num in numbers. And so we're taking the temporary variable and multiplying it by 2. We're doing num multiplied by 2. But it's strange because I thought that in square brackets you put things separated by commas. And here we've just got space, various things, we've got a sort of multiplication operator, a temporary variable, a keyword, and they're just separated by spaces. And so it's really quite strange, this. Let's break down our example in a more general way. New list has assigned to it expression for elements in and then the collection. And you can see that's what we just had. So we had an expression which was 2 num multiplied by 2, and then we just have a space and then we can begin with the word for. Let's read. In our doubled example, our list comprehension 1 takes an element in the list numbers, 2 assigns that element to a variable called num, which is our element, 3 applies the expression, the multiplication, applies the expression on the element stored in num and adds the result to the new list called doubled. And 4 repeats steps 1 to 3 for every other element in the numbers list. Our result would be the same. 4, minus 2, 158, 66, and minus 90. Which is what we got when we had it using this nice and understandable syntax, where we had 4 in on its own line and no square brackets surrounding the 4 in construction. So the point is, this funny way of doing it with where you can put an expression in square brackets and then just a space and then your 4 in construction, that will get the result as well. Okay, why are there square brackets? Well, you'll notice that we don't. So what's happening? We have the 4 in loop kind of within the square brackets, and remember the square brackets are assigned to doubled, and we're printing doubled. So we're saying, so it is a more elegant way of doing it. It's more compact. Right, so up here, what we had to do is we had to say, okay, here's doubled, and doubled is a list, and it's an empty list. And we had to refer to that. We had to say doubled dot append. So the loop was making reference to that empty list, doubled, because ultimately we're going to be printing doubled. Here what we're doing is, instead of having the loop refer to the empty list, it's as if the loop doesn't need to refer to the empty list, because its very position, the very fact of where the loop is in the list. It's in the square brackets of doubled, isn't it? And so what's interesting is now that we don't actually need a body for our loop. Right, so just to be clear what's happened here. Yep, there's no body now. There's no colon, is there? Usually it's for x in y, colon, and then the body. There's no colon here. So we don't need to kind of bolt on the end of the 4 in the body, because the very location of 4 in is so just makes it clear that makes it clear where we want to sort of express what we have churned out. Because remember, an expression is a statement where we take 2 entities, perhaps a variable like num, and we take something else like the value, which is a constant 2, and then we do something to them. In this case, we multiply them, and then we squeeze out a different value, a single value. That's what an expression is. We express something. We literally push something out that's a single value from having had multiple inputs. And so the question is, well, where do we express? Where do we squeeze out? It needs to know. Someone needs to know where to put it. With this construction here, we're saying squeeze out the value and add it to doubled, right? Doubled dot append. So how do we communicate that information about where to put the squeezed out thing here? Well, we don't have the word, as I said, we don't have the word doubled, which is sort of in the 4 in loop or after the 4 in loop. We don't even have the word append either. So we're not using that method. We're not saying here's a list doubled dot append. So it is just the way Python works, that by putting the expression in that first portion of the square brackets, it knows you're communicating that you want the value, the thing the expression evaluates to be put here. So you just place the expression where you want its result, let's say, to be put. Right, so just to make explicit, that's what's going on. And that's why it's more elegant. We don't actually have to even mention doubled. That's why it's more elegant. There's one mention of doubled, and you're putting the expression you want to collapse down to evaluate to something where you want it to evaluate. So it's a different way of communicating. You're communicating by placing the expression actually in the place you want it to be. It's almost like gesturing. Whereas here, we're not really gesturing. We're saying, right, take number multiplied by 2 and put it in doubled. We're explicitly saying here, put it in doubled. Append it to doubled, which is over there. We're not actually putting the expression in the place we want it. We don't want the expression to evaluate here in the loop, do we? I don't even know how that would work. And we print the text of the loop, the keywords, with what number multiplied by 2 is equal to under the for in line. It doesn't even make sense. The point is, what we do here is we say number by 2 needs to be put in the listicle double dot append, but the expression isn't actually in the blanked out square brackets, whereas here we're putting the expression where we want its result to be. And you can do that. Let's break down our example in a more general way. Okay, and we've been through this. So new list, and we're putting we're assigning the square brackets to the variable name, and we're just saying the first part has the expression, which might be a multiplication, an addition, some complex thing, and then space for in collect, and then you name the collection. So you're kind of writing the loop backwards, aren't you? Because the expression is not unrelated to the for in. You know, what we want to do is we do want them to be linked. We're saying we do want you to do this expression for the elements in the collection. So we're kind of writing the loop backwards. We're doing the body first, then a space, then the word for. Instructions. 1. We have been provided a list of grades in a physics class. Using a list comprehension, create a new list called scaled grades that scales the class grades based on the highest score. Since the highest score was a 90, we simply want to add 10 points to all the grades in the list. So perhaps you don't know what it means to say scale the grades. Don't worry about it. Our task, our job, is just to add 10 to all the grades in the list. So if we've got a 90, 88, a list of elements, we can use a for in loop, can't we? So I'm going to say for grade in grades colon, but no, we need to use list comprehension. Well, let's see how we would do it using using the classic syntax. So I'd say for grade in grades colon take grade and add equals to 10, and then we'll have a new variable called scaled grades, and that will have some blanked out square brackets. What I want you to do is take scaled grades and put them in there. So I'm going to do scaled grades dot append, and I think I can just put grade because I don't have to kind of package it up in a new word distinct from grade, because on this line we have changed the value of grade. So I can just I can just follow forward and say, okay, append grade. I think that works. And then finally, after the for loop, print scaled grades just to see if it's worked. So I think this is how I'd do it using classic syntax. So for grade in grades, I've got my colon, take grade, which is the element, add it to 10, and then scaled grades dot append grade. I think that works. And that will be the value which has had 10 added to it. So that has worked. Instead of 90 being the first element, we've got 100. Instead of 88, we've got 98. Instead of 62, we've got 72. Instead of 76, we've got 86. Okay. Now let's do it using the elegant syntax. Scaled grades is equal to, and then I'm going to work within these square brackets. First, the expression grade plus grade add equals to 10 space for grade in scaled for grade in grades, and that's it. For in, I don't need to ever type out append, A-P-P-E-N-D, because I know what I'm appending to. I'm already in the square brackets of scaled grades, so I don't need to do scaled grades dot append. No. So I'll comment out this line or these lines, and then print scaled grades. Okay, so it says scaled grades, grade add equals 10, and it says there's a problem with this add equals operator. Can I not have spaces there? It looks like you've encountered a syntax error due to an invalid syntax in line 12. The error is caused by the use of the for loop and list comprehension syntax together incorrectly. Go on. Well, in Python, list comprehensions should be used with the syntax expression for item in iterable. Well, that's what I've got. Expression for item in, and then grades is my iterable. Yeah. Oh, maybe it's because I've still got this line here. Let's keep reading. In Python, list comprehensions, here's how you can fix line 12. Oh, they've just put grade plus 10 for grade in grades rather than plus equals. So why could I not put, why could this not be add equals? Because I thought add equals was used to update the list of a variable. So if I just put add, it works. I think and if I change it to add equals, we get an error. So why can't I use the add equals operator? The add equals operator is used to modify a variable in place, which is not allowed in a list comprehension. List comprehensions are meant to create new lists by evaluating an expression for each item in an iterable. The expression should be a simple operation that returns a value, not an in-place modification. In a list comprehension, you can use operations like plus, take away, multiply, etc. to compute a new value. But you can't use add equals, you can't use take away equals or star equals, which are assignment operators. Those are assignment operators. This is an example of an assignment operator. These operators are used to update variables, not to compute values for list comprehensions. So perhaps the thought is, grade doesn't really exist anywhere. There's no line where we say grade will set it to begin with to be 0, and then we would be updating it. But there isn't such a line. Remember, grade is our temporary variable. It's a kind of ephemeral thing, so perhaps that has something to do with why we can't be sort of assigning things to it as if it's sort of there, existing. It's not. All we can do is say, okay, the expression we write here has to be something that can be made use of in every sort of little iteration of the loop. Every iteration of the loop is like a little parallel world that we temporarily enter into and then we leave. And then we enter into and we leave. We can't be updating grade, because grade, because it assumes that grade is sort of part of the persisting furniture throughout the loop iterations, but it's not. It doesn't work like that. After each iteration, we clear the stage and it's a new scene. So you can't be using these sort of assignment operators. Let's end it there.